Good morning and welcome to UniFood Day. Today is the day in which you have joined us because you want to follow the ongoing food science. Perhaps you want to innovate yourself or research. I'm called Heidi. I work as an innovation manager for Food and Biocluster Denmark, and I have the honor and pleasure of taking you through today, and I will be in excellent company. I've been lucky that the multinationals Nestlé. Let me see if I can also change the slide a little bit. I've been lucky that Nestlé, IFF, and Tetra Pak, three of the large corporates working within food, have each identified topics and sent them to us as scientific questions or questions to scientists. We have handpicked 9 scientists that have engaged in the dialogue, and today they will be bringing state of the art of their research that is related to this topic to enlighten both the companies that have asked the questions and you, and also the rest of us, and you, the participants. Yeah. So welcome everyone. Just before we get started, I'd like to just mention how the program is going to work. We will have 3 sessions. One starts now, another one starts at 10:15. And the third one will start at 11:30. We will focus in the first session on precision fermentation and dairy proteins. In the second session, we will be talking about off flavors in plant-based products. And in the third session, you will hear again about precision fermentation, but at this moment, we will be discussing the sustainability aspects of this new technology. There are a couple of practicalities that I'd like to start out with before we really run to the first session. And that is that unfortunately today, it's only the speakers that are visible. So all of you attendees, and I know there have been plenty of interest for joining, and welcome to all of you, but unfortunately we won't be able to see you as we have a version of Zoom which doesn't allow for pictures. And yet your questions are both interesting and welcome. So what we do is my colleague Louise sits here next to me, and she will be taking in the questions as you ask them in the chat session. As there are many people here, I can't promise we will answer all of the questions, but we will try our best in the discussion sessions in each of those 3 sessions. And the questions we don't answer there, we will try to see if we can answer them afterwards. So then you can send them to us by email. Yeah. Now, of course, there is no such thing as a free lunch. And I have to make sure that you are all aware that this day would not have been possible without the support from the Danish Ministry of Higher Education and Science. So thanks to them for us to be able to do all of this. But I think, without further delay, one more thing that I should mention is that we are making a video of today's session, and we will be sending out the presentations from the day. So you don't need to take notes on everything. On the other hand, some speakers are bringing details to the table today that they will not be able to share in the presentations afterwards. So do stay attentive. And you will also be able to get access to the video afterwards if there are details that you find you need to just see again, or you need to share with a colleague. Yeah. Okay, without further delay, I think we should jump into the first session. And I am extremely happy and honored to have here with us today Christophe from Nestlé, who is with us from Switzerland. Also Professor Lotte Bach Larsen from Aarhus University, as well as Associated Professor Sayed Tohail Mansouri from DTU, and Marija Banovic from Aarhus University. Perhaps I could ask you to just turn on your cameras. There you go, Lotte. Fantastic, thank you so much. And I can see, I think, maybe it's my view. I can't see all of you. I'll just see if I can do something here so that I'm sure I can see the whole panel. There you go. Yeah, this is much better. perhaps some of you, the guests, might want to do the same and just check if your settings are good so that you can see the whole panel. At least it helped me to have a different view, so you can run through it. Yeah, excellent. Well, Christophe, obviously you are the company representing the company in this session, and we're really happy that you have brought a question to our scientists. But I think it's much better that you introduce it yourself. So I will now see if I can find your presentation. Christophe, maybe you should introduce yourself and say who you are. Then I will find your presentation meanwhile.
Thank you, Heidi. Good morning, everyone. First of all, I would like to thank you again for the invitation to attend this session. Shortly on myself, so I'm Christophe Schmidt. I'm working at Nestlé Research in Lausanne, Switzerland, where I'm basically a protein expert, and I'm in charge of specifically plant proteins. I know there is a session on that one afterwards, but I'm also involved in I would say activities which are related to precision fermentation as far as proteins are concerned. And this is a bit the topic which I would like to introduce and would like to discuss in the frame of this first session.
Wonderful.
So Heidi, when you're ready with the slides.
I am ready.
Be happy to. Thank you. So I hope I can get control now.
Click one time and I think it should work. Yeah.
Yes.
Calculated.
So basically, to introduce the session, I would like to discuss emerging technologies for sustainable food systems. So these slides I've put together with my colleagues who are involved in this topic. So Michael Mertz and Oliver Schmiel, as well as Wilco Kleins and Cédric Dubois. So why basically we are interested in emerging technologies at the level of Nestlé? It's because on the broad actually view, we have to rethink the way we source and manufacture foods because we need to ensure food security and involving consumer needs. There are 5 at least elements which contribute to that broad question. The first one on food security, I think you all do know that the world population is growing. This was not me.
Sorry about that. I was turning off my video. Maybe you can stop back with your arrow.
Yes, let me go back. So coming back, so world population is increasing. So the forecast is 10 billion people by 2050. Of course, we need to feed all these people. And one of, I would say, the bottleneck is how do we get enough proteins to feed these people? So there is clearly a demand to have sustainable protein sources there. One additional topic is that more and more consumers, they are particularly concerned with animal welfare, being actually meat protein sources or other animal sources like egg, like dairy. Sustainability already talked about. We need to make sure that we can produce these volumes of proteins within the planetary boundaries because there is no way we can actually increase them. Also, there is unmet consumer needs, which maybe we can actually answer with using these proteins, like, for example, lactose intolerance, taste, specific nutritional profile, and of course, food quality, which is, I would say, non-negotiable. It's a given. We need to make sure that we deliver food quality. So why is cellular agriculture of interest for Nestlé? And in cellular agriculture, actually, I'm just considering cell-based meat, which we will not discuss here, and precision fermented dairy proteins. Well, it's because it's a new technology which actually has several potential benefits related to what I was just saying. So in principle, you can actually get rid of the animal problems because you don't need the animal actually to grow the proteins. It could be on the paper, and we need there to find out how the sustainability is impacted, but most of the data are showing currently that in principle we would be better than the animal proteins. health and nutrition, you can still deliver good quality proteins. And of course, if you control well the production conditions, you can ensure food security. What we want also to do is to test this ingredient in food formulation and understand how they affect nutrition, taste, and texture, because we need to see if we can process them on our lines and what's the final outcome. And also very important, we need to validate the potential benefits with the consumer and the environment. So this leads us actually to the question which we have put forward to our colleagues from the universities, related to dairy proteins by precision fermentation, which one have the biggest potential. And to answer that, actually the idea is to consider aspects on feasibility, functionality, nutrition, and consumer perception. And just before I hand over, one additional slide to let you know that you may have seen that at Nestlé we have already started in this topic. End of last year in the US, we have run actually an accelerator project with a product which was called Coabunga. So basically it is a beverage which actually is using animal-free dairy protein from Perfect Day. It had good nutritional and functional benefits, also suitable for vegans and lactose-free. And this was our first attempt actually to launch such a product based on precision fermented proteins, and to see a bit what was the consumer feedback. I will not be able to go into big details regarding the outcome of the study, but this is just to let you know that we are active in this field and we are not alone. So now I would like to get the input from our colleagues, and I thank you for your attention.
Great, thank you, Christophe. So I think this is very clear, very good question, and very timely or topical, one might say. And actually, we have 3 scientists with us today who each have their perspective on the question that you're addressing here, both in terms of qualities perceived by the consumers and qualities when it comes to how to produce them. We have with us Lotte Bach Larsen, who is a professor at Aarhus University and is a researcher in the field of food proteins from animal and plant sources, and also researching in the impact of production factors and processing, both on composition and properties, and also is leading research on cellular agriculture. And Lotte, you have some insights that you would like to share to enlighten us on the topic of what to look for in dairy proteins. And I'll see if I can find your slides. Here we go. And
thank you, Heidi.
Yes, there we go. And I just need to make sure that everybody can see it, so not only me. I should hand over for you.
Thank you, Heidi. You can hear me, right?
We hear you perfectly well, Lotte, and we look forward to hearing what you're bringing.
I think this is probably not the first slide. I think there is a title slide.
You will probably have to swap back.
Yeah. Yeah.
There we go.
Thank you. Good, and thank you for the opportunity to present some of our work. And it was really nicely framed by Christophe Schmidt, so thank you for that. And I will talk a little bit about some of our use and projects within cellular agriculture and precision fermentation. And as you can see here already now, I'm maybe distinguishing a little bit between cellular agriculture and precision fermentation. And it just illustrates that we don't have the formal naming in place now in this new emerging area, and that's how it is when new things are coming. I think it's a little bit different with how we name the stuff and so on, but we'll come back to that. So we have different projects within the cellular agriculture of milk proteins. And here are shown 2 schematic drawings of that. The first one to the left is illustrating precision fermentation that Christophe also mentioned. And we have a project under Novo Nordic Foundation where we look at production of different milk proteins, and there you then use a cow DNA first. Then you insert it into bacteria or yeast or other organisms by recombination, which is an old technique known from enzymes, for example, during many years. Then you add some nutrients. You have a fermentation where the microorganisms produce the proteins that you have inserted DNA for, and then you can purify. And that is often called precision fermentation or genetically modified products. And then we also have the other one to the right, where we use cells from the cow. And those cells can be from the udder, or they can actually be isolated from milk. And these are epithelial cells like the ones we have on our skin, but these represent cells from the udder creating milk. And then the idea is that we can grow these cells, and then we can, oops, that was a little bit too fast. Does it change by itself? And then we can, I just have to move this a little bit. So in principle, harvest what comes out of that. And sometimes we call mainly the concept to the right as cellular agriculture and the one to the left for precision fermentation. But I think there's no overall agreement on what we call it. So I think it's something that probably will be sorted out in the future. Heidi, I think I can't change the slide. Oh, now it comes. It's just very slow. I just have to be patient. So this is whoa, sorry for that. So if we then take the concept of precision fermentation a little bit closer, as I said, it's no from the enzymes, but not for bulk food. And therefore, if we want to use precision fermentation as a source of proteins for bulk food and not just for enzymes or ingredients as such, then there needs to be a lot of focus on upscaling and purification and the properties of the proteins coming out of it, of course. And these are the steps, part of the precision fermentation, as I mentioned earlier. It's just a little bit more pinpointed out. And then after the genetically modified steps, then we have the different purification steps. Oh, I don't know what's happening here. And then you can analyze the proteins that has been precision fermented by different protein chemistry techniques. There has currently been made a report from DCA at Aarhus University that has been led by AU Food, and in that one, future alternative proteins were kind of mapped, and it was kind of discussed and framed and mapped that alternative proteins seem to have a lot of production potential and also over a timeline. And for example, we can see that the precision fermentation is lying on a kind of a long side, more than 10 years up in the top. But it's also said that if we can do improvements, for example, use waste streams on new organisms for upscaling, then it's evaluated that this precision fermentation is able to increase very much in its production potential, and maybe even be taken into real use much earlier, as also Christoph said. So it's actually on the breakthrough just at the moment. And then again, as I said, it's actually changing without I'm pressing any button, but I'm just trying to steer it a little bit. As I said, there is a lot of discussion about terminologies, but I already discussed that a little bit. And there's also discussions with the milk industry and the dairy. Heidi, I'm actually not sure what's going on.
I'm not sure either. Why don't we say you tell me when I should, so I'll take the control back, and then you can tell me when you want to swap slides, because it seems it's running a little around with us. This
Yeah,
was
I
the
think
slide you
so.
wanted to talk about, right?
Yeah.
Yes. So let me swap for you. I think that's a little easier.
If you take the next one. Yeah. And it is.
Right. This is really funny.
Yeah.
What is happening here? Stop remote
I don't know.
control, and I will see if I can go back. It is on my computer, so you know, this is where we go, and I will keep the control.
Yeah. Okay. We'll see how it goes. Sometimes the technique just runs away with us.
Yeah.
Yeah, and we are in the dialogue with the dairy industry, and also, of course, they talk with the different partners and so on. How are we actually using the terminology here, and what can we can we use the word as milk? But that's nothing we can kind of land here. But I think it's a very good consideration on how we can denote it, and also when we come to the consumers and so on. So please take the next one.
Yes.
And there's a lot of activity in this area, also framed by Christophe. And I have tried to organize here some of the small startup, or not even maybe small, but some of the startup companies within the two areas of single cell and fermentation-based protein, and the cultivated milk that we call it when we isolate the cells from the cow. And apart from these startup companies, also, as we heard, a lot of many of the big dairy players are also into this area now, and considering how to move on within these areas. The next one, please. And when we look at milk, we have two major groups of proteins. We have the caseins and we have the whey, and this is kind of a background slide about that. I'm not going to take all the details, but mainly now within especially the precision fermentation area, there has been most focus on the whey proteins, and especially on the beta-lactoglobulin, while the caseins, which are actually the major part of the milk, has been less produced by precision fermentation. And I think that's because there is a lot of problems with getting the right functionality of the caseins, because they have some very specific features, even though they are the major ones now utilized in dairy products. And the next one, please. And this is because when here we have the caseins, all these small bubbles and decorations on the backbones of the protein sequences is specific features of the caseins that actually gives them the specific calcium binding properties that makes them so fantastic when we use them in food and dairy production. And these specific decorations that I have drawn here, or we have drawn here, they are normally not made by the microbes that we use for precision fermentation of the caseins. So that is a problem. That means that the casein made by the microbes don't have calcium binding activity, and therefore they cannot have the same functionality in foods that we want to make. And the next one, please. And here we can see a schematic representation of how a casein micelle may look. And this is these round bubbles that have specific features that, for example, when we make cheese, then the green molecules at the surface of this casein micelle is shaved off, and then the casein micelles can clump together, and that is a part of what is happening, for example, when we make yellow cheese. But also the properties of these micelles are extremely important for every other feature of when we utilize the caseins in foods. And that is also why they can bind the calcium, as I mentioned. And therefore, it's important to introduce these modifications to get the right functionality. And the next one, please. So that is where we are currently having most of our science in the precision fermentation area. That is very much on the choice of the target proteins. We're also considering, can we have some dream design? Now we can play a little bit around with the molecules. We can even maybe improve the caseins or the food proteins. How do we make the constructs? And that, I have to say, that's done in collaboration in my projects with DTU. We're not the ones making the precision fermentation. I'm doing that together with some colleagues from DTU. And they have to, we have to consider yield, and we have to consider how can we make these decorations to obtain the functionality. How can we make purifications and ingredients free from genetically modified organisms? There's also considerations on whether the proteins that are being made by the microorganisms, are they secreted out in the surrounding liquid when we ferment, or are they kept into the organisms called inclusion bodies and then have to be purified in another way? We have to consider fermentation media, and can we reuse the cells, and how can we then use it as food ingredient? What is the legislation and what is consumer acceptance? And I think we'll hear more about that. Thank you.
We definitely will. Thank you so much, Lotte, for a very interesting and insightful presentation. Also, thank you for giving us some definitions in the beginning so that we know what we're talking about. And I know that our next speaker, Sayed Sohail Mansouri from DTU, has an opinion on some of the points that you have made, and not the least on whether we call it milk or milk protein. I'll let you say what you want to say, Sayed, but I'll just introduce you. You are an associate professor of system design at DTU Chemical Engineering Department, and you focus on the process systems engineering with a focus on dynamics of complex technical systems and multi-scale modeling. You also focus on smart biomanufacturing, technological developments, and you like to take a holistic view to data-driven or mechanistic understanding of the biomanufacturing from molecule to enterprise. I hope everybody got all the words. But I know you know a lot about the whole system, and especially with a focus on the process. If you turn on your microphone, we can not only see you but also hear you. And I think I'll see if I can find your slides. And let's see if it works for with a remote control. If not, we'll do like before, but we'll give it a chance.
I try.
Yeah.
So I click on the screen. Doesn't seem like working.
It does.
Yeah, it does. All right. All right. Thank you very much, Heidi, for my long and complex introduction. So so I'm going to talk about and I want to also re-emphasize that milk proteins are more than just milk, that Lotte you mentioned. So coming to that, I mean, pretty much we're talking about the era of biology and the fermentation of proteins, anything from food to milk to human oligosaccharides to cow milk, etc. Different terminologies being used, but we're talking about a growing market. We're talking about a growing consumer market that is pretty much around, let me see the number. It's around $20 billion within the next 10 years. So there's a lot of room for development and coming up with alternative food. And as you also showed, Lotte, in your slides very nicely, there are a number of different initiatives, startups, research, commercial, etc., looking into this. But discovery is different than delivering, and this is actually a notion that I took up from our collaborating partner, 21st Bio, which is a Danish company, that they are also looking into basically developing beta-lactoglobulin through fermentation. But what we're talking here is that going from shake flask dynamics and yields to a larger scale that fulfills the economics of a scale for consumer affordability, meaning that it is going to be an affordable source of protein, and while maintaining the current prices or even cheaper for the consumers, while we provide them the nutritious value, is a challenge. So the missing link here is the process. How do we get there? So when we go from the lab scale and we want to go eventually to the full scale, often we are dealing with a scale that is called the pilot scale, which is in between. And the idea of the pilot scale, and why is it called the Death Valley, for many of these organisms is basically that many of these startups and initiatives need to fulfill the economics and the business case promised at this scale. If not fulfilled, then there's too much of a risk to put down the steel required to build a full-scale plant in lieu of uncertain economic gains. So here's where the data and how we can actually move from the lab scale to pilot scale becomes apparent. Okay, now it's not moving. All right. So one of the main challenges for going from the lab scale to full scale, and on our way from a few milliliters to a few liters to a few cubic meters, is that how we can capture actually the right dynamics of these cells. When we come to the larger scale fermentations, we deal with a lot of mixing effects. How do we deliver the nutrients to homogeneously throughout the fermentation medium, and depending on the type of organism. So there is a difference if you are using bacteria or yeast or filamentous fungi when it comes actually to this scale up. The dynamics are completely different. Cell viability during the fermentation is very, very important. Gaining right information on monitoring these processes is a task that we're now working with our collaborating partner, 21st Bio, to decipher this basically pipeline by introducing monitoring technologies like pretty much non-invasive technologies like online image processing or capacitance spectroscopy and so forth. Once we're past that, still the pilot scale is not the commercial scale. So when we are talking about the pilot scale, I mean, we are talking about 1,200 liters, 2,000 liters before we go larger. And as we go larger, the costs of brute force experimentation increase exponentially. That is where the modeling strategies to develop predictive models using the data that have been acquired from the lower skills combined with the mechanistic models that describe the higher skills become very useful to develop process economic models for the viability of an investment in an available organism and how we can bring it to the market. And this is also part of the area that we are working. So if I want to now look at the wider picture, what we're now working on and we are building up, there are some projects also at DTU, some of my colleagues are involved, is to basically, can we now start thinking of combining the multi-omics data at the cell level, gain the current understanding of the metabolic pathways, combining those models and the data at various scales with the cell behavior dynamics, and try to actually have some predictions, more accurate predictions of what would likely happen at a full scale. So these are the main problems that we are basically dealing with. Reaction, estimating the underlying reactions in the process, and estimating active metabolic pathways, distribution of substrates in cell mass and products, which are mainly transport properties within the fermentation media, and also correlating process measurements such as cell viability, the state of the reactor, substrate and cell distribution within the reactor, and this whole thing adds a level of complexity for monitoring and diagnosis requirements, and that is what we are seeing as a key to this scale up by developing more advanced soft sensors that can come together with hard sensors, meaning that instead of waiting until in the optics community and other adjacent fields of sensing technologies, we arrive into, for example, an online measurement technology that we can measure the protein in the fermentation medium. Can we now infer that from the existing measurement that are available through the model-based techniques? So now when we are looking now past fermentation, where we're talking about this is not just the fermentation. We also need to know where is the cutoff point after this fermentation of these kind of proteins. For example, is it enough that after the fermentation and one step purification, we take the slush and sell it to the end user for the formulation? Or do we need to go all the way towards the product purification? These all entail economic risks and decision making in terms of also product formulation. We need to actually have an integrated understanding of a wild state of our processing. Would it be sufficient to be used in the formulation? Because additional processing steps require additional costs, energy, and water to be used. And not only that, there's not only one way that we can produce them. What you can see here is for another case of, for example, succinic acid, which is also another bulk biomolecule produced in this superstructure. There are 14,000 feasible alternative pathways to produce succinic acid, for example. It's not that different for also milk protein when it comes to the purification. There are a number of feasible pathways towards the final end goal and the cutoff point to go to the product formulation. That this requires actually deliberate decision making to guarantee the economic and environmental benefits. So what brings me to my last point is that there is a need that we actually take a holistic approach, combining cell level dynamics all the way to the enterprise-wide level considerations. And that is a concept that we are actually working on, and we call it integrated cell product process design, that we can actually integrate these areas. So what you can see in this example plots, there's also a consideration of the capacity of the plant, because the case of milk proteins is very actually analogous to the case of, for example, succinic acid that has its alternative coming from petroleum, right? In the case of milk proteins, we also have the animal-based competing with the bio-based. So there are minimum selling price fluctuations that basically towards a final product, there is a requirement for actually an optimum capacity of the plant that makes it economically robust for these productions. After we have selected the strain, solved the scale up, let's say we have fermentation at scale, and then taking it all the way back. So I just conclude my presentation again with the example of succinic acid. Succinic acid is a great example that I think precision fermentation community should take the learnings from that example. There were 4 succinic acid plants built in the world. All 4 went bankrupt. And there were various reasons for them going bankrupt. One of them being that the companies had a great strain, had a great process, but they didn't actually ask for the right amount of money for the right capacity of the plant that they had built. Number two was that the companies were too biased, not on the best strain, but on the strain that they had IP on. So there is also other considerations when we look into bringing this into the market. And I know these are not technical, but if you look at it from a systems point of view and a holistic view, that is where the technology and economic risk analysis, let alone the environmental aspects, need to be carefully considered. I think Mikkel Hauschild and Peter Fantke in the next session will also touch base upon that one. I mean, the amount of water being used, and also the treatment and the energy and et cetera, needs to be carefully reviewed. With that, I just conclude here. Thank you very much.
Thank you so much, Syed. I'll see if I can take back the control stop. Right, let's see if that helps. Thank you, Syed, also for bringing up the aspects of feasibility in terms of financial feasibility. Is this at all economically viable, and how many not successful startups will we see within this business? I think we are all a little worried about this. But so far we've been listing up from Lotte some considerations to take when you're picking your type of protein. So Syed is looking a lot at the process and how to use AI in all the process. But this is not the only types of concerns you have when you're a multinational such as Nestlé. You are also pretty concerned what the reaction from the consumers will be once you are adding new ingredients or bulk produced new types of foods. And that's exactly what Marija Banovic is going to introduce to us. Thank you so much, Sohail. We will get back. Actually, just before finishing off this presentation with you, Sohail, I have one explanatory question, which is you were mentioning 21st Bio as an example of a startup that is working within this field. I just wanted to make sure that everybody is aware. Is this company both working with the cell-based, precision fermented meats and dairy proteins, or just one of them?
Well, I cannot take position on behalf of the company. Our collaboration is on beta-lactoglobulin.
All right. Thank you so much for clarifying. All right. Let's move on to Marija Banovic from the MAP Center of University of Aarhus. You are an associate professor of consumer behavior at the MAP Center, and you do research on the value creation in the food sector. For instance, you look at the consumer acceptance of new foods, and you've also done some research on alternative proteins from plants and microbes and hybrid products, even hybrid products that is not really being discussed today, but maybe some of the learnings that you're bringing to the table can be transferred even to talking about ingredients made by precision fermentation. I'll find your presentation, Marija, and hand over everything to you.
Thank you.
It's not this one. And the word and the floor is yours.
Thank you, Heidi. Okay, and thank you for inviting me to this event. I think it's really important that we talk about these things, and especially the consumers, because that's kind of the last step before we go to the market, as Heidi said. And I will talk a little bit about how we can actually unveil this consumer acceptance of the precision fermentation. I will focus on animal-free dairy. We conducted several studies. I did previously also studies on sweet protein, but I won't mention that. I will give you just some links at the end so you can take a look at it after. So let me see. Yes. Okay. So I know it looks a little bit too many things on the slide, but I will just start by saying that kind of, if we are looking at all the startups that we have now on the market, they're kind of navigating quite some challenge. First of all, in US, what we have now for securing to be able to go to the market, we need to have this self-affirmed GRAS status. And that's kind of the first step for commercialization of these precision fermentation foods. And GRAS status means that ingredient is safe to be used in food and beverage. And it's kind of this, let's say, regulatory green light for the manufacturers. For now, in the US, there are 3 companies. We have Remilk, Imagine Dairy, and Perfect Day. And they've also formed this alliance, Food Fermentation Alliance in the US. You have the other companies that I have listed here that do not have the GRAS status. But Perfect Day, as Nestlé also showed the product Kavabanga, they also collaborate with other companies like Brave Robot, making ice cream, Nix, California Purification, and so on, Mules, and so on. When we are looking at the Europe, we have also Food Fermentation Europe Alliance that was recently formed, actually in the spring of this year. What is happening there that due to the strict novel food regulations, some of these companies are actually forced to launch to the other markets. And what kind of it's said is that Europe is not grasping actually the opportunity to market this product that could have significant contribution to sustainable food systems. Imagine Dairy is actually helping this alliance, and if you go to their website, they have their own website, you will see that what they're doing is actually trying to advocate for this non-discriminatory market-based regulatory framework in EU. And that's kind of ironic, you know, when I'm looking at the farm to fork, which is kind of already old news, around 10 billion euros is actually invested in farm to fork to alternative proteins, and one of the 4 key areas of that investment, it goes to microbes. So then kind of something doesn't fit there. And then if we're looking at the literature, what we heard also from Lotte and Sai is that it is predicted that precision fermentation will definitely disrupt the agriculture and the food. But when I'm looking at the consumer and the previous studies on genetically modified organisms, microbes, and so on, we know that the consumer is not so easily acceptable towards this product. That's something different, of course. This is very much related to the culture itself. We know that this is not the case, for example, for US, mostly is related to Europe when I'm saying this. So so besides all the problems that we have in Europe, kind of with the regulations and so on, I can say that these precision fermentation companies are kind of navigating the uncharted waters. So not only that they are kind of have to fight with these new regulatory frameworks and so on, but they are also contesting against the habits, the aspirations, cultures of the consumer. And let's see, now I will show you several studies that we have done on this topic. This is only for animal-free dairy that I'm going to talk. This is in progress. We just collected the data a month ago. First of all, we wanted to see, let's see what the consumer actually think about the precision fermentation technology. What we found out, we conducted a study actually across 4 countries in Denmark, France, Germany, and UK. What we found out that majority, as you can see here on this word cloud, that they think that this technology is quite artificial. They are fearful, a bit skeptic about the technology. But on the other hand, there are a group of consumers, after we have conducted a sentiment analysis, thinking also that this is also could be a smart thing to move on, it's the future, and so on. And then we have a group of consumer, another segment that is kind of ambivalent, thinking that this is too complex to comprehend and they need more information on this. Then we went more in depth and we said, okay, so if we have all this, there is this group of consumers that they don't understand really what it is. And then there is another one that thinking this is really something difficult and deceitful or something like that. We wanted to see how we can actually communicate about this kind of technology to get the consumer on board. So we first used simple communication strategies like using, is it a sustainable technology, is it natural? And what we found out that using wording like natural, naturally, bringing it more closer to the nature is actually working much better in terms of communication than using framing as sustainable. This is even more important if it aligns, of course, with the mindset, with the goals, values of the consumer, of course, with a particular consumer segment. Then we went more in depth. We said, okay, this is too complex. Even when we are talking about these things, maybe we should use some simple heuristics, some nudges, kind of to nudge them gently into accepting this kind of technology. What we used the familiarity cue and representative heuristics, where we just thought, okay, we would just say, well, this technology is something that you already know. It's something that, like a traditional fermentation, where we can compare it with, for example, production of beer or yogurt or bread and so on. And what we found out that those cues actually work much better, and even as a standalone strategy, much better than even using some complex communication frames. Then we went more in depth. We wanted to see, like, okay, so we have these different groups of consumers and so on, and we wanted to look at the personality traits, because we are hearing all these things about, well, it has to be healthy in terms has to be at the same level in terms of nutrition and sustainable and so on. So we look at the different personality traits and then how these could influence their perceived benefits about the technology, but also some negative sentiments that we found. What we found out that besides the consumers who have higher levels of health consciousness, environmental consciousness, that definitely can influence and boost the benefits they see about the technology. What is important that they have the trust in the manufacturer. So kind of that the production process is transparent and trustworthy. When we look at the perceived benefits, they were always weighted against these negative sentiments that consumers have, and mostly in this case because of lack of the explanation to the consumer, mostly technology phobia, and then which brings forth the skepticism with regards to technology. But then we went and saw that there is this, again, this group of consumers who are actually risk takers and who like to buy unfamiliar products, and they're bored with the conventional products, and saw that they will be the one kind of, let's call them early adopters. I don't like to use that word, but trendsetters who would be more acceptable towards this new product, and in this case, animal-free dairy. You have here all the links that we of our projects and all the that are also related to the slides I've previously shown. We have also conducted studies on the sweet protein, and I can tell you, if I have to kind of compare the animal-free dairy produced, so the dairy protein produced by precision fermentation and the sweet protein, my experience is that sweet protein, because it's seen as something more healthy, and it's kind of confronted with sugar, because we are substituting, for example, protein instead of sugar. And in this case, we have something that is functional, that is conventional, something that is kind of daily. It's more difficult there to substitute the products than when we are looking at the sweet protein. And there we also had we conducted studies with different types of products, also functional, indulgent, pleasurable products, and some of them are we worked with my company from Israel, and they already have some of these products on the market. Yes, so that was it from me. Thank you so much, and I'm looking forward to the discussion.
Thank you so much, Marija. Indeed, time is running, and actually our session is almost over. We will have to eat a little from the break in order to give Christoph a chance to ask some questions. First of all, one clarifying question for you, Marija, to the 4-country study you made. Were the consumers aware of that precision fermentation is GMO?
Yeah, we explained that we did a very nice graphic. I couldn't actually show you because, you know, the study was funded. So we are supposed to submit a report at the end of the year. Yes, we did a very nice graphics where we explained how actually, very similar to something that Lotte showed in the beginning. So how we take the from the cow and we implant it and we feed the microbes and then it's purified and so on. We didn't use the words GMO. We say the DNA modifications and so on, because of our experience in the previous, studies with GMO organisms that induces all these kind of yak factors and so on with the consumer.
Fantastic. Thank you, Marija. And I could mention also that a study will come out, what we call a focus analysis from Food and Biocluster in the end of this year, beginning of next year. A report will come out. Right. Christophe, we've been through quite some interesting points now. And it's time for you to, if you have some questions to these 3 scientists. Unfortunately, I'll have to put all questions from the audience to the side because you have the floor for the next 3 minutes, or you and I will have. Are there any specific questions you'd like to ask to Lotte or Sohail or discuss, or your opinion on this?
Yes, indeed, quite some questions, but let me try to be fair. So if I can have one question for each of them, so that we can cover the whole topic. So the first one I would have, it's to Lotte on the selection of the protein. So you said rightly that caseins are more complex actually to produce because they have some post modifications. But indeed, these modifications are very helpful for nutrition and for technology like calcium binding. So what is your view on actually the production of caseins as a dairy protein? Should actually the startup continue to invest in that? Should they actually invest in more simple proteins? And when we have what we have, what is your view on that one?
Thank you, Christophe. Well, I think probably there's room for both strategies, but I think it's a matter of what product that you want to aim at in the end. Because if it's like your example of the collaboration with the yeast fermented beta-lactoglobulin, for example, that could be added into drinks or ice cream and so on in hybrid products, then I think it can give some amino acid balance or some additional functionality or perceived consumer acceptance that it contains some animal-based proteins in a mixture of other proteins. And then I think it can be fine to select some more simple proteins. But if you want to go for exchanging the more maybe known dairy products, maybe into some mixed products, but where you want to achieve the very famous properties of the well-known dairy products and the good amino acid balance and digestibility of the milk proteins, then I think it's maybe a good strategy to consider to include the caseins and how we can modify them to make some products that resemble or maybe exchange or resemble to some extent what we know today. So I think it's really important to consider the product in the end. Okay. And then we can also consider about the human caseins, but that's another discussion maybe.
That's true, yeah. At least this is one of the options also offered by precision fermentation. We can trigger also the composition. Thank you, Lotte. I would have a question for Sohail, because I think there was one important point he mentioned, and I think probably very worth considering on the economical viability, on to which level of refinement do you have to go with your protein source to be still able actually to be viable? So what would be your opinion on actually which level of refinement should we stop at? Should we consider actually the concentration of protein which you have actually in cow's milk? How would you approach that one, Sohail?
Well, as I said, I mean, I cannot for sure say what would it be, because that really depends on the final product formulation. But perhaps in some product formulation, an up concentration to a certain level, having a slush form in solution may work, especially, for example, if you want to work it out with drinks and so on and so forth, because also most of these organisms are GMOs, and at least the regulation in Europe requires us to actually do a quite more expensive purification. So the earlier we can actually fulfill the regulation, after we fulfill the regulation, then I think the door is open on what we can do for it. But also another aspect to it is the side streams. These processes will have massive side streams, that they are also nutritious for side cultivation of other proteins, for example, microalgae. So there are a few spins to actually make the economic viability of this. That is why holistic and integrated decision support strategy needs to be taken into account, scenarios to be analyzed. You know, as I also wrote in the chat box, I mean, we need to really do a lot of input parameter uncertainty assessment, you know, sensitivity analysis, because also a lot of numbers, whatever we take before we go to full scale, or even a full scale, will not be really deterministic. And there will be quite a lot of uncertainty. And that is why the capacity will work as a buffer to basically work that around. But to more precisely answer your question, I think there is also a lot of room, on the other hand, to innovate based on a feasible cutoff point, if I want to think it through.
Thank you so much, Sohail. I am so sorry to be the dictator, saying that now we will have to cut off in respect of the next sessions. May I invite all of you speakers to just check in the webinar chat, because I can see that everybody can see all the questions. So in case you can answer some of the questions in there during the break, that would be awesome. And perhaps if you feel that your question was not answered in the audience, you can forward them to me or my colleague Louise, and we will try to connect you with the right person who can probably answer your question, because the whole point of today is dialogue. And I feel there is so much for you, the speakers, also to continue discussing the scenarios and aspects that you'd like to take into account. So Christophe, I hope that you are walking out of at least the first session enlightened a little bit, maybe with added more complexity, but at least also with some new knowledge that you might be able to use.
Definitely. Thank you very much for organizing. Very helpful, and for sure I'll be in touch actually with the speakers after the meeting.
Wonderful. Thank you so much.
Thank you for your input.
Thank you, everyone. And thanks to all of you in the audience as well. We will start up the next meeting in maybe 7 minutes rather than 5. You saw that Marija was bringing also a word cloud to her presentation here. Now I'd like all of you to take out your mobile phones, because there will be a word cloud when we come back from the break. Now there is a break for 5 to 7 minutes. See you soon. Thank you so much for now.